Okay, so the doubly linked list is much better and much easier and much simpler than a singly linked list, because here the additional advantage is that not only you can move from left to right, but you also can move from the right to the left. So for example, we can denote doubly linked list like this. What it means is that you can move from 1 to 2, and you can also move from 2 to 1. Similarly, you can move from 2 to 3, and you can move from the 3 to 2. Right. So in a doubly linked list, each node stores three information: the information about what data it is storing, the information about what is the next node, and the information about what is the previous node. Right. So the extra flexibility that we get in the doubly linked list is that now we can move in both the direction. We can move in the left direction also, and we can move in the right direction also. Right. And since we can move both the directions, lots of problem becomes very simple, because now the doubly linked list is as good as a simple array, because in the array you can move in the left direction as well as in the right direction. Right. Similarly, in a doubly linked list, since we can move in both the direction, it becomes much more simpler. So if you have to solve a same problem which you are solving in the linked list with a single linked list, with a doubly linked list, the problem becomes much simple. For example, if I have to add two numbers, 1, 2, 3, like this. So these are the two numbers, 1, 2, 3, and another number is, say, 7, 8, 9. Now this problem, by solving with the doubly linked list, becomes much simpler. The reason being that now I don't need to reverse it. What I can go to the tail here, and I go to tail here, and I keep on adding it and moving to the left as I used to do in a proper simple array, right? So a problem which is coming in the form of the doubly linked list is much simpler to solve than the single linked list. So doubly linked list is a much simple data structure than what a single linked list data structure is, because we can traverse in both the directions. So everything that we did in the case of the single linked list remains same for the doubly linked list as well, except that it will have one extra pointer which is pointing to the previous node also. So if I have to define a DLL node, I can define like this: class DLL node. Okay, so it will have two things. It will have a private data, and then it will have private DLL node. Next, okay. Except that everything that you do remains the same. Everything that you do, how do you find the length, how do you traverse it, how do you update it, how do you insert an element, how do you delete an element, everything that you do remains the same. The one extra precaution that you have to do here in the doubly linked list is that initially in a single linked list, when you are inserting an element, you only have to update the next pointers. But when you are inserting a new element or updating an element or deleting an element, you have to update both next as well as previous pointers. This is the only extra care that you need to do. So all the methods like, public, void, traverse, public, and length, okay. Then we have to public DLL node insert. Right? Please go ahead and implement this method. Any problem in this? Will you guys be able to do these things? Implementation of all the DLL methods.
Yeah.
Right? It is pretty much simple. It is same as what you do in the single linked list. So this is about doubly linked list. Okay. And normally you will see a doubly linked list is much easier to solve than a single linked list, again, because there is no constraint of the movement. You can move in both the directions.